So today, as Emily mentioned, I'm going to talk about some work we've been doing on trying to better prepare our landscapes for recovery after a wildfire. So, um, high severity burn area is increasing across the western U.S., as I'm sure everybody on this call knows. It's driven by the combined effects of fire exclusion, which increase tree density and fuel loads, and then we've got increasing atmospheric dryness, which are making those fuels more available to burn. And so these large high severity burn patches are problematic from a tree regeneration perspective. We've got areas that are just basically too large for seeds to disperse into because the most of our conifers have fairly heavy seeds and their dispersal distance is not real far. So we've been focusing a lot on planting trees into the planting seedlings into these high severity burn areas. One of the challenges, though, here in the Southwest is that we've got a much hotter and drier environment and relatively low survival rates. And so this figure you see here is from a paper written by Jesse Utz that looked at different post-fire planted seedling survival across the Southwest, Arizona, New Mexico, and found mean survival was just 25%. And so, those are some challenging numbers to deal with. So a big part of that is really all about the thermal environment and how challenging it is for seedlings to survive without any sort of overstory canopy. The soil surface temperatures can reach lethal levels for seedlings. So this is a thermal image from the Las Conchas fire footprint on the east flank of the Jemez Mountains in northern New Mexico. So we took this image last August. Substantial areas of what you're looking at are reaching 44 degrees Celsius, 111 degrees Fahrenheit. And in one of the surveys we did in our work where we looked at Forest Service planted seedling survival in this area, we found a survival rate of just 13% after 3 years. And that has a lot to do with the fact that these little things are getting cooked. So basically, the situation report for the Southwest is we've got increasing high severity burn area. Uh, we need more artificial regeneration as a result, but we've got really low survival because of changing climate and that extreme thermal environment. And so there's a real potential that we see a range contraction for regeneration with additional climate change. And then, so as a result, we're really looking at a narrowing window for when to get trees established in these landscapes because the fundamental niche space, the climatic conditions that the seedlings will tolerate, that range of conditions is much narrower than adult trees. So we have an ongoing program of research to try and improve planted seedling survival in post-fire footprints, and we're doing that by looking for areas where seedlings are more likely to survive. So we've undertaken several studies, starting with seedling planting in the Las Conchas fire footprint in 2016, where we instrumented planting sites to measure microclimate at seedling height so we could relate it to climate data. We planted across a range of topographic positions, and then we mapped those planting locations with UAVs so we could build high resolution 3D surfaces of planting sites. And then we used all this information to try and understand what factors were good predictors for whether or not a planted seedling would survive. And so what we found is that we could characterize the landscape with a number of different measures of topography, like heat load index, topographic wetness index, topographic roughness index, slope, and then a topographic position index. And those, all those indices are really strongly correlated, of course, with microclimate because they're influencing the amount of incoming solar radiation. And so we found that we can use that information to make predictions about where planted seedlings will survive with the probability that they'll survive with 63% accuracy. And so, we can predict that survival. We found heat load index, topographic wetness index, and incoming solar radiation were really important predictors. And what you see is this the model output on the right here is really all about characterizing that Las Conchas fire footprint. And the red dots are our experimental plantings, and the white dots are Forest Service plantings that we measured to validate the model. And the bright white areas you see, so the bright white, like in the upper right-hand corner, are areas with a high probability of survival, and the black areas are a zero probability of survival. So we designed the data workflow for this project so that we can assimilate new data and re-estimate those probabilities relatively easily. So we're building on this current model with an ongoing project where we planted ponderosa pine across a much larger elevation range. And so that we can characterize that environment better. We're also working to incorporate the effects of shrubs on planted seedling survival because they shade the seedlings and alter microclimate. And then we're going to assimilate those data into the predictions as well. And we're beginning to work with the Jemez Pueblo to acquire sufficient data so we can build a Douglas fir model. So we've worked primarily on ponderosa pine up to this point. And so all of this is structured such that as more reforestation happens in the Southwest, we can assimilate those data and improve model performance. So part of the reason for this work is really encapsulated in this figure from a paper we did led by Joe Fargione, where we looked at, basically what our capacity is in this country for producing seedlings and doing reforestation, and found out where the bottlenecks are. And so what we're doing here in the Southwest to loosen some of those bottlenecks is really the kind of heart and soul of the New Mexico Reforestation Center effort. And so the NMRC is a partnership between New Mexico State University, New Mexico Highlands University, UNM, and the New Mexico Division of Forestry. And as far as that seedling pipeline goes, we're working on building a seed bank. So Highlands has got an active seed collection program going. We're working to build a modernized facility that can grow 5 million seedlings a year and service the Four Corners region. And because we've got 3 academic institutions involved, there's a lot of effort focused on workforce development. And then, of course, the modeling that I mentioned earlier is we're really building this whole thing around a data-driven approach to reforestation to increase survival. So the idea is that if we can plant fewer seedlings out and have more of them survive, that's going to loosen some of the constraints on seed and then the whole production. So we'll be able to actually reforest more acres. So to date, we've secured about $40 million. We need an additional $70 million for the entire build out. The NMRC is going to be located in Mora, New Mexico. We're in architecture and engineering phase right now, and working on acquiring the remainder of those dollars. And so hopefully we'll have those secured sometime in the next 6 to 12 months, so we can undertake the entire construction at once. And with that, I'm happy to take any questions.